My name is Caroline Culpepper, and this is my Laboratory 5 report. For my introduction, I wanted to start with the fundamentals that were used in this lab, which were Newton's second and third laws, and Faraday's law for induced current, where any change in the magnetic environment of a circular conductor will cause an EMF to be induced in that conductor. The objectives of this experiment were to determine the magnetic force on a falling magnet due to the induced current loop, which was an aluminum foil roll, and then model the magnet and tube interactions using GlowScript. The main result from this experiment was that multiple opposing forces acting on an object, which was the magnet, can create a decrease in the downward velocity of that object. So the experimental setup, dimensions of the roll of aluminum foil were taken. Then, through using a recording device, a magnet was oriented and dropped through the roll of aluminum foil. This was repeated 5 times, and the time spent in the tube was recorded and averaged to yield the most accurate results. For the results section, I wanted to start with the expected result without induced current, which was that the magnet would only experience a downward gravitational force. I calculated that using the mass of the magnet, and you can see the magnitude of the force in the negative y direction. From application of the right-hand rule, we know that induced current is counterclockwise, so the force on the magnet is upwards, which would reduce the magnitude of this force in the negative y direction. So my actual results with induced current was that the magnet did experience a stall and downward motion, and the average time spent in the tube was 2.55 seconds. My code, which I broke up into 5 parts, is shown on this slide. So first I inputted the values for tube dimension and bar magnet properties. Then I calculated the magnetic field of the bar magnet and the magnetic flux. I then computed the magnetic field in each ring, and then calculated the net force, where F grav was equal to this vector. And then I updated the magnet's velocity and position, which is shown in the image below. And here's a video of my code. You can see as the magnet falls through the tube, and then the graph and time are shown below. The model predicted that the magnet would spend 4.5 seconds, which was 2 seconds longer than what I actually observed. And so some final questions regarding this experiment. The intensity of the coloring on the tube indicated the magnitude, and so I received that blue corresponded to the counterclockwise direction and red to the clockwise, because the north end of the magnet was to enter the tube first, and this would induce a counterclockwise current. If the magnet was flipped around, the magnet would still realign with the magnetic poles of the Earth, so it would not affect the dynamics of the system. And the total time in the tube was greater in my computational model, so accuracy could have been increased by taking into account or eliminating some of the other competing forces that may have been present in working on the magnet, or through improving the value of the magnetic moment of the bar magnet, which I calculated roughly in Laboratory 3. The shape of the velocity versus time plot demonstrates the observations that originally only the downward force of gravity is working, and then the upward magnetic force starts acting, which slows the downward velocity of the magnet until it exits the tube, and gravity is the only acting force again. If the resistivity of the magnet were reduced to 0, or if the resistance of the conductor was reduced, the magnet would move slower, which is according to Ohm's law. And then if holes were cut in the tube, it would work similarly to breaks in a circuit, or where there would be less theoretical rings, less loops, and therefore the magnetic force would be reduced. So for my conclusion, multiple forcing acting on an object causes a decrease in downward velocity of that object, which we saw in the experiment and aligns with Newton's second law. And then errors in previous calculations become more visible through further calculations, and external or uncontrolled variables can cause deviations from theoretical values as well. Thank you.